March 10, 1943, Pembroke, Wales. The metallic shriek of tortured metal echoed across the Welsh countryside as a Focke-Wulf 190 Anton-3 fighter carved a violent furrow through a farmer's field. The aircraft's broad radial engine cowling was crumpled, its landing gear torn away, but the fuselage remained remarkably intact. Oberleutnant Armin Faber had just executed what would become one of the most consequential navigation errors in aviation history. His disorientation during a dogfight over the Bristol Channel had led him to mistake the Welsh coast for France, landing at what he believed was a Luftwaffe base. Instead, he had delivered Nazi Germany's most feared fighter directly into British hands. Within hours, Royal Air Force personnel surrounded the crashed machine, weapons drawn, as Faber emerged from the cockpit to face the stunning reality of his mistake. The aircraft he had flown, Werk No. 5737, bearing the fuselage code White 2-3, was about to reveal secrets that would fundamentally alter how American pilots fought the air war over Europe. This single captured fighter would travel across the Atlantic to Wright Field, Ohio, where American test pilots would discover tactical vulnerabilities that would transform the Republic P-47 Thunderbolt from a struggling heavyweight into the Luftwaffe's most deadly adversary. The revelation would come not from German engineering failures, but from understanding how to exploit the FW-190's design philosophy against itself. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Focke-Wulf 190 had entered Luftwaffe service in the summer of 1941, immediately establishing itself as a formidable opponent that shocked Allied pilots accustomed to fighting the Messerschmitt Bf-109. Where the 109 was angular and cramped, built around a liquid-cooled inline engine that required careful temperature management, the FW-190 featured a massive BMW 801 radial engine that could absorb tremendous battle damage and continue running. The aircraft's wide-track landing gear made ground handling forgiving compared to the narrow, delicate gear of the 109 that had killed numerous pilots during takeoff and landing accidents. Most significantly, the FW-190 introduced an entirely new level of firepower to the European theatre. The Anton-3 variant carried two 7.92mm MG-17 machine guns mounted above the engine, synchronized to fire through the propeller arc, and four 20mm MG-151/20 cannon, two in the wing roots and two in the outer wing panels. This devastating armament package could destroy a heavy bomber with a single well-aimed burst, and proved absolutely lethal against Allied fighters, whose pilots survived long enough to recognize the distinctive radial engine cowling before the FW-190's guns spoke. British intelligence had been tracking the FW-190's combat debut with growing concern throughout 1942. Combat reports from Royal Air Force pilots described an aircraft that rolled faster than the Supermarine Spitfire Mark V, the RAF's frontline fighter. Pilots reported the German fighter could dive away from pursuing Spitfires with ease, accelerating to speeds the British fighter could not match without risking structural damage. The FW-190 seemed to possess an incomprehensible combination of firepower, speed, and maneuverability that violated every assumption about what was possible with a radial engine fighter design. German propaganda emphasized the aircraft's superiority with typical bombast, but in this case, the claims appeared disturbingly close to truth. RAF Fighter Command faced a crisis. The Spitfire Mark V, which had dominated the Luftwaffe during the Battle of Britain just 2 years earlier, now found itself outclassed by both the improved Messerschmitt Bf-109 Gustav and especially the new Focke-Wulf 190. British pilots were dying, and the reasons remained partially mysterious, because intelligence could only piece together fragmentary combat reports and gun camera footage that captured the FW-190's performance in fleeting glimpses during the chaos of aerial combat. The Air Ministry desperately needed a complete, intact FW-190 to study under controlled conditions. They needed to understand exactly what made this aircraft so formidable, and more importantly, they needed to discover its weaknesses. Every aircraft possessed vulnerabilities, points where design compromises created exploitable limitations. The challenge was finding them before too many Allied pilots paid with their lives for that knowledge. Several damaged FW-190s had been recovered from crash sites across England during 1942, but most were too badly damaged for meaningful flight testing. One aircraft, Werk No. 5863, had been captured relatively intact in June 1942 after Oberfeldwebel Otto Bechtold force-landed near Pembroke following engine failure. The RAF managed to repair this machine and conducted limited test flights at the Royal Aircraft Establishment in Farnborough, providing the first solid technical data on the FW-190's capabilities. But that aircraft suffered from uncertain maintenance history and potential hidden damage that made test pilots cautious about pushing it to its absolute limits. What British and American intelligence truly needed was a pristine example, fresh from the factory, flown and maintained according to Luftwaffe standards, that could be tested without concerns about pre-existing damage affecting results. Oberleutnant Armin Faber provided exactly that on March 10, 1943, though his delivery was entirely unintentional. Faber was no novice pilot gambling with an unfamiliar machine. He was an experienced fighter pilot with Jagdgeschwader II, one of the Luftwaffe's elite fighter wings, with multiple combat victories to his credit. On that March morning, his Staffel had engaged RAF Spitfires over the Bristol Channel in one of the constant skirmishes that characterized the air war over Western Europe. The engagement had been fierce and confusing, with aircraft wheeling through the sky in the three-dimensional chaos that defined aerial combat. During the violent maneuvering, Faber became disoriented. In the adrenaline-fueled confusion of combat, with his attention focused on tracking enemy aircraft and avoiding their guns, he lost track of his position relative to the English and French coasts. Fighter pilots in that era navigated primarily by dead reckoning and landmark recognition, with no GPS, no sophisticated navigation aids, just a compass, a watch, and visual references that could become dangerously ambiguous during combat maneuvering, especially over water, where one coastline might look remarkably similar to another when viewed from 20,000 feet. As his fuel state became critical and he needed to land immediately, Faber spotted a coastline ahead and an airfield. He assumed, with the certainty born of expectation rather than careful verification, that he had crossed back over the English Channel and was approaching occupied France. The airfield below appeared suitable for landing, and with fuel tanks running dry, Faber had no time for extended reconnaissance or careful position verification. He entered the landing pattern, lowered his landing gear, and brought the FW-190 down for what he thought was a routine recovery to friendly territory. The moment his wheels touched Welsh soil and he saw British markings on aircraft parked nearby, Faber realized his catastrophic error. He attempted to take off again, advancing the throttle and trying to get the fighter back into the air before British personnel could react. But his fuel tanks were nearly empty, and the FW-190 barely had enough fuel to taxi, much less take off and fly back across the channel. The engine coughed, starved of fuel, and the aircraft rolled to a stop. Within minutes, RAF personnel surrounded the disabled fighter, and Faber emerged to face capture, his disbelief and shock evident to the British soldiers who took him into custody. The Luftwaffe had just lost one of its most valuable tactical assets through a navigation error that would haunt Faber for the rest of his life. Royal Air Force intelligence officers could barely believe their fortune. Here, sitting intact in a Welsh field, was a pristine FW-190 Anton-three, Werk No. 5737, fresh from the factory with just over 100 hours total flight time. The aircraft had been manufactured at the Focke-Wulf plant in Bremen and delivered to Jagdgeschwader II in February 1943, less than a month before Faber's capture. It represented the current production standard, with all the latest modifications and improvements incorporated during manufacturing. Most remarkably, the aircraft was essentially undamaged. Faber's landing had been controlled and professional, despite his shock at realizing his mistake. The landing gear had collapsed due to the rough field surface, but the airframe, engine, and all major systems remained intact and functional. With relatively minor repairs, the aircraft could be restored to full flying condition and tested without concerns about crash damage affecting performance. The captured FW-190 was immediately transported to the Royal Aircraft Establishment at Farnborough, where technicians began detailed examination while simultaneously planning the repair work needed to make the aircraft airworthy. Security around the captured fighter was extraordinary. Armed guards surrounded the hangar 24 hours per day. Only personnel with specific clearance could approach the aircraft. The British understood they possessed an intelligence treasure whose value could hardly be overstated, and they were determined to extract every possible piece of tactical and technical information before word of the capture leaked to German intelligence. British technicians worked with impressive speed to repair the landing gear damage and restore the FW-190 to flying condition. They replaced the damaged landing gear struts with components fabricated in RAF workshops, repaired minor damage to the wing tips and fuselage, and conducted thorough inspections of the engine and all major systems. The BMW-8 114-cylinder radial engine, producing approximately 1,670 horsepower at takeoff power, underwent complete inspection and testing to ensure reliability during flight tests that would push the aircraft to its limits. By early April 1943, less than a month after Faber's forced landing, the captured FW-190 was ready for its first flight in British hands. Test pilot Captain Eric Brown, already renowned for his skill in evaluating captured German aircraft, was selected to conduct the initial test flight. Brown had extensive experience flying both Allied and captured Axis aircraft, and possessed the technical knowledge and flying skill necessary to safely explore the FW-190's performance envelope while carefully documenting its characteristics. On April 14, 1943, Brown climbed into the FW-190's cockpit for the first time as pilot rather than curious examiner. The cockpit impressed him immediately with its thoughtful ergonomics and excellent visibility. The wide-view canopy provided exceptional situational awareness in all directions, far superior to the cramped, heavily framed canopy of the Messerschmitt 109. The instrument panel was logically arranged with clear, easily readable gauges, grouped by function. The control stick and throttle fell naturally to hand, and the rudder pedals were positioned for comfortable leg geometry. German designers had clearly prioritized pilot comfort and ease of operation, recognizing that reducing pilot workload and fatigue translated directly into combat effectiveness. Brown started the BMW 801 engine, which caught immediately and settled into a smooth, powerful idle. The sound was distinctive, a deep rumble from the large radial engine that vibrated through the entire airframe. He advanced the throttle, and the FW-190 accelerated smoothly down Farnborough's runway, the wide-track landing gear keeping the aircraft stable and controllable throughout the takeoff roll. The fighter lifted off after a remarkably short ground roll, testament to the powerful engine and efficient wing design. Brown climbed away from Farnborough, carefully exploring the FW-190's handling characteristics at various speeds and altitudes. What he discovered during that first flight, and in subsequent test flights over the following weeks, would fundamentally reshape Allied understanding of the German fighter and provide the tactical intelligence that would save countless Allied pilots' lives. The FW-190's roll rate was extraordinary, the best Brown had experienced in any fighter. The aircraft could snap from full deflection in one direction to full deflection in the opposite direction faster than a Spitfire, faster than an American P-38 Lightning, faster than anything in the Allied inventory. This roll performance came from the combination of relatively light, well-balanced ailerons and a low polar moment of inertia, created by concentrating the aircraft's mass near the centerline. In combat, this exceptional roll rate meant the FW-190 could change direction with startling rapidity, making it extremely difficult to track in a gun sight during maneuvering combat. Allied pilots who tried to follow an FW-190 through a rapid rolling maneuver found their own aircraft lagging behind, unable to match the German fighter's angular velocity. By the time the Allied pilots' guns came to bear on where the FW-190 had been, the German aircraft had already rolled to a completely different flight path. This performance advantage explained many combat reports from frustrated Allied pilots who described being unable to get their gun sight on an FW-190 even when they appeared to have positional advantage. The dive performance was equally impressive. The FW-190 accelerated rapidly in a dive, reaching speeds that matched or exceeded most Allied fighters. More importantly, the controls remained effective and relatively light throughout the dive, allowing the pilot to maintain precise control at very high speeds. Many Allied fighters, including the Spitfire Mark V, experienced severe control stiffening at high speeds, making it difficult or impossible to pull out of steep dives without using both hands on the stick and tremendous physical effort. The FW-190, by contrast, maintained good control, harmony, and responsiveness, even at terminal velocity. But Brown's systematic testing also revealed significant weaknesses that German pilots either didn't recognize or hadn't reported. The FW-190's climb rate was good, but not exceptional, inferior to the Spitfire Mark IX, and significantly worse than the American P-47 Thunderbolt at high altitude. The BMW 801 engine, despite its impressive power at sea level and low altitude, lost effectiveness as altitude increased. By 25,000 feet, the FW-190's performance degraded noticeably, with reduced acceleration, decreased climb rate, and less responsive handling. Most critically, Brown discovered that the FW-190's turn performance was decidedly mediocre in sustained turning combat. The aircraft could execute one or two tight turns using its energy advantage, but in a prolonged turning engagement, the FW-190 bled energy rapidly. The wing loading was relatively high, meaning the aircraft needed to maintain higher speeds to generate sufficient lift for tight turns. Once the FW-190 slowed below about 250 miles per hour in a hard turn, it wallowed, the controls became mushy, and the aircraft became vulnerable to opponents who could maintain energy better in sustained maneuvering. This weakness was profound and exploitable. It meant that despite the FW-190's impressive roll rate and dive performance, a skilled pilot in an aircraft with better sustained turn performance could force the German fighter into an engagement geometry where the FW-190's advantages disappeared. The key was avoiding the initial slashing attack where the FW-190's speed and roll rate dominated, then forcing the German pilot into a sustained turning fight where the Allied fighter's lower wing loading and better power-to-weight ratio at reduced speeds provided the advantage. Brown documented these findings in detailed test reports that were immediately distributed to fighter command squadrons. For the first time, RAF pilots received concrete, tested information about exactly how to fight the FW-190 and win. The aircraft was no longer a mysterious superweapon whose capabilities seemed almost supernatural. It was a well-designed fighter with specific strengths and specific weaknesses. Allied pilots who understood and exploited those weaknesses could defeat the FW-190 consistently, even when flying theoretically inferior aircraft like the Spitfire Mark V. But the true strategic importance of Faber's captured FW-190 emerged when the aircraft crossed the Atlantic to the United States in summer 1943. The Americans were facing their own crisis with the FW-190, but their problem involved a different Allied fighter, one that was supposed to be invincible but was instead struggling desperately against the German radial engine fighter. The Republic P-47 Thunderbolt had entered combat over Europe in April 1943, just as the captured FW-190 was completing its initial test flights at Farnborough. The Thunderbolt was the heaviest, most powerful single-engine fighter ever built to that point in aviation history. Weighing over 14,000 pounds fully loaded, powered by a massive Pratt & Whitney R2800 double Wasp engine producing 2,000 horsepower, the P-47 looked like it could simply batter its way through any opposition through sheer brute force. American pilots nicknamed the fighter the Jug, short for Juggernaut, reflecting both its intimidating size and its reputation for being able to absorb tremendous battle damage and keep flying. The aircraft could withstand hits that would destroy lighter fighters, and its .850 caliber Browning machine guns delivered devastating firepower. But in early combat operations over Europe, the Thunderbolt struggled badly against the FW-190, losing pilots and aircraft at rates that alarmed 8th Air Force commanders. The problem wasn't the aircraft's absolute capabilities, which were formidable. The issue was that American pilots didn't understand how to employ the Thunderbolt's strengths against the FW-190's specific characteristics. They were trying to dogfight in a heavyweight fighter, accepting turning engagements where the P-47's tremendous weight became a crippling disadvantage. FW-190 pilots quickly learned they could lure Thunderbolts into slow-speed turning fights where the German fighter's lower wing loading provided decisive advantage. Once the Thunderbolt slowed below 300 miles per hour, trying to turn with an FW-190, it became a ponderous, vulnerable target that German pilots dispatched with casual efficiency. By mid-1943, 8th Air Force, fighter groups flying the P-47 were suffering unsustainable losses, and pilot morale was deteriorating. The men flying the massive Republic fighters felt they had been given an inferior machine and sent to fight a superior opponent. Some pilots openly stated they would rather fly the older P-38 Lightning or even the P-40 Warhawk, both of which had serious limitations but at least could turn with German fighters. The crisis reached the point where some American commanders questioned whether the P-47 should be withdrawn from combat operations entirely and relegated to ground attack missions where its rugged construction and heavy firepower would be assets rather than its poor turning performance being a fatal liability. Then, word reached Wright Field that the British had captured a pristine FW-190 and conducted extensive flight testing that revealed specific tactical weaknesses. The U.S. Army Air Forces immediately requested the aircraft be shipped to the United States for American test pilots to evaluate, particularly focusing on how the FW-190 performed against the P-47 Thunderbolt. The British agreed, recognizing that American success in the air war over Europe served British strategic interests. In July 1943, Faber's captured FW-190 was carefully crated and loaded aboard a cargo ship for the Atlantic crossing. The aircraft arrived at Wright Field in Dayton, Ohio, in early August, where it was reassembled and prepared for a comprehensive test program that would prove as consequential as the British testing, but for different reasons. The Air Technical Service Command at Wright Field assigned the captured FW-190 to its fighter test section, where some of the Army Air Force's most experienced test pilots would conduct direct comparative trials against American fighters, with particular emphasis on the P-47 Thunderbolt. Colonel Cass Huff, who commanded the fighter test section, understood that the testing program needed to provide immediate, actionable tactical intelligence rather than simply documenting performance specifications. American pilots were dying over Europe, and the test flights needed to answer one critical question. How could Thunderbolt pilots defeat the FW-190 in combat when every instinct and every element of their training told them to turn and fight, precisely the tactic that was getting them killed? The test program began in mid-August 1943, with careful documentation of the FW-190's performance characteristics under controlled conditions. American test pilots flew the captured fighter through standardized test protocols, measuring climb rate at various altitudes, maximum speed at different power settings, turning radius at various speeds and altitudes, and control response throughout the flight envelope. These tests confirmed what the British had already discovered. The FW-190 was an exceptionally well-designed fighter with extraordinary roll rate, excellent dive performance, and good low-altitude speed, but with mediocre sustained turn performance and degrading capabilities above 20,000 feet altitude. But the truly valuable testing came when American pilots began flying mock combat missions, pitting the captured FW-190 against various American fighters under realistic combat conditions. These comparative trials would reveal tactical insights that no amount of isolated performance testing could provide, because they simulated the dynamic, three-dimensional geometry of actual aerial combat, where relative performance between two aircraft mattered far more than absolute specifications measured in isolation. The first series of comparative trials paired the FW-190 against the P-47 Thunderbolt, the aircraft that was struggling most desperately against the German fighter over Europe. The results of these initial mock combat sessions were sobering, and initially seemed to confirm every pessimistic assessment about the Thunderbolt's suitability for air superiority combat. When the two fighters began mock engagements at co-altitude and co-speed, simulating the mutual visual acquisition that typically initiated combat, and when the American test pilot flying the Thunderbolt attempted to engage in traditional turning combat, the FW-190 dominated completely. The German fighter could turn inside the massive Republic fighter with ease, getting into firing position within 2 or 3 turns, while the Thunderbolt pilot struggled helplessly to bring his guns to bear. The FW-190's superior roll rate meant it could reverse direction faster than the Thunderbolt could follow, constantly forcing the American pilot to lag behind the turning fight. In these slow-speed turning engagements below 300 miles per hour, the P-47 appeared hopelessly outclassed, a ponderous heavyweight being toyed with by a nimble opponent who could strike at will while remaining immune to counterattack. But then the American test pilots began experimenting with different tactical approaches that leveraged the Thunderbolt's actual strengths rather than attempting to match the FW-190 in areas where the German fighter held inherent advantages. They tried engagements where the Thunderbolt pilot refused to slow down and turn with the FW-190, instead maintaining speed and using the P-47's exceptional high-speed performance to dictate engagement geometry. The results were dramatically, almost shockingly different. When the Thunderbolt pilot maintained speed above 350 miles per hour and avoided sustained turning, the P-47's advantages emerged with devastating clarity. The Republic fighter could dive faster than the FW-190, accelerate more rapidly in level flight at high speed, and maintain its energy state far better during high-speed maneuvering. Most significantly, the Thunderbolt's controls remained effective and relatively light at very high speeds, where many fighters, including the FW-190, experienced severe control stiffening that made rapid maneuvering difficult or impossible. The test pilots discovered that when a Thunderbolt maintained 400 miles per hour or greater and used boom and zoom tactics, diving from altitude to make a single high-speed firing pass, then zooming back up to altitude using excess speed to regain height, the FW-190 pilot found himself almost helpless to respond effectively. The German fighter could not match the Thunderbolt's dive speed without risking structural damage or control lockup. It could not follow the Thunderbolt's zoom climb without bleeding all its energy and stalling. And most critically, if the FW-190 pilot tried to reverse and engage the climbing Thunderbolt, the American pilot could simply roll inverted and dive away again, using the P-47's superior high-speed roll rate and dive acceleration to escape before the FW-190 could bring its guns to bear. The mock combat trials revealed a fundamental truth that transformed how American pilots understood the Thunderbolt. The aircraft was not a dogfighter, and attempting to use it as a dogfighter played directly into the FW-190's strengths while abandoning the P-47's decisive advantages. But when flown as a high-speed energy fighter that used altitude, speed, and vertical maneuvering rather than horizontal turning, the Thunderbolt could dominate the FW-190 by simply refusing to fight on the German pilot's terms. Colonel Huff and his test pilots documented these findings in detailed tactical bulletins that were distributed throughout 8th Air Force fighter units in Europe. The bulletins were remarkably specific and practical, written by pilots for pilots, focusing on exactly what to do in various tactical situations rather than abstract discussions of performance specifications. The guidance was revolutionary in its directness. Never, under any circumstances, attempt to turn with an FW-190 at speeds below 350 miles per hour. The Thunderbolt cannot win that fight. Instead, maintain speed, use altitude advantage to dive on the enemy, make one high-speed firing pass, then zoom back to altitude before the German pilot can react. If caught at low speed by an attacking FW-190, do not try to turn. Instead, roll inverted, split S into a dive, and accelerate to maximum speed. The Thunderbolt can outdive any German fighter, and once at high speed, can out-accelerate them in level flight. Use the P-47's exceptional high-altitude performance above 25,000 feet, where the FW-190's engine loses power significantly and cannot maintain energy in combat maneuvering. The tactical bulletin emphasized that the Thunderbolt's greatest advantage was its ability to choose when and how to engage. At high speed, the P-47 could run down any German fighter, engaging when advantageous. Equally important, it could disengage from unfavorable situations simply by diving away and accelerating to speeds the enemy could not match. This tactical flexibility meant Thunderbolt pilots should never accept combat on German terms, instead forcing the enemy to fight at high speed and high altitude, where the Republic fighters' strengths dominated. The impact of this tactical intelligence on 8th Air Force operations was immediate and profound. Fighter groups received the bulletins in September 1943, and commanders conducted intensive training to break pilots of their instinctive tendency to turn and fight. The training emphasized discipline, the absolute requirement to maintain speed and altitude even when every combat instinct screamed to turn into an attacking enemy. Pilots practiced boom and zoom attacks repeatedly until the tactical sequence became automatic. Spot the enemy, maneuver for altitude advantage, dive at high speed, fire during a brief window when the target filled the gun sight, then zoom away before the engagement could develop into a turning fight. The results appeared in combat within weeks. Thunderbolt pilots who rigidly applied the new tactics found the FW-190 transformed from a nearly unbeatable opponent into a manageable threat that could be engaged with reasonable confidence of success. The key was discipline, refusing the temptation to pursue a maneuvering FW-190 into slow-speed combat, where the German fighters' advantages would prove fatal. Several 8th Air Force pilots credited the tactical intelligence from the captured FW-190 with directly saving their lives during combat encounters that would have been fatal had they followed their initial instincts. Captain Gerald Johnson of the 56th Fighter Group described engaging a formation of FW-190s over France in October 1943, diving from 28,000 feet at maximum speed. He fired a long burst into one FW-190 that exploded dramatically, then continued his dive rather than attempting to climb back into the fight at low speed, where remaining FW-190s could have engaged him advantageously. He zoomed back to altitude well away from the furball, then set up another high-speed diving pass. By the end of the engagement, Johnson had destroyed 2 FW-190s without ever allowing German pilots to force him into the turning fight where their aircraft held advantages. Lieutenant Robert Johnson, no relation to Gerald Johnson, had an even more dramatic experience in June 1944 that demonstrated both the Thunderbolt's ability to absorb punishment and the value of understanding FW-190 capabilities. Johnson's P-47 was severely shot up by an FW-190 that caught him at low altitude during an escort mission. Rather than attempting to turn and fight, Johnson dove for the deck and accelerated to maximum speed, pushing his damaged Thunderbolt to over 450 miles per hour at low altitude. The pursuing FW-190 could not match this speed and eventually broke off the chase. Johnson nursed his battle-damaged Thunderbolt back across the English Channel and landed safely at his base, his aircraft bearing over 200 bullet and cannon shell holes. The damage would have destroyed most fighters, but the rugged Thunderbolt absorbed the punishment and brought its pilot home. Johnson credited his survival to understanding that his only chance was to use the P-47's speed advantage to escape rather than accepting combat in the FW-190's preferred envelope. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The tactical transformation of Thunderbolt operations extended beyond individual survival techniques to comprehensive changes in how American fighter groups employed their aircraft strategically. 8th Air Force commanders restructured escort tactics to maximize the P-47's high-altitude performance and long range, while minimizing situations where Thunderbolts would be forced into low altitude, turning combat against German fighters. The new tactical doctrine positioned Thunderbolt formations at 28,000 to 30,000 feet altitude, well above the bomber formations they were escorting. From this position, Thunderbolt pilots could observe the entire tactical situation, identify German fighters attempting to attack the bombers, then dive on the enemy at high speed from superior altitude. The altitude advantage translated directly into speed through the dive, giving Thunderbolts crushing energy superiority during the critical first pass where most kills occurred. German pilots who survived the initial diving attack found themselves at low altitude and low speed, exactly where they wanted to fight. But the Thunderbolts were already climbing back to altitude rather than remaining to dogfight. This tactical approach, enabled by understanding the FW-190's specific performance characteristics, revealed through testing the captured aircraft, transformed the strategic air campaign over Europe. German fighter pilots could no longer force American escorts into prolonged low-altitude combat, where Luftwaffe numerical superiority and the FW-190's turning performance would eventually prevail. Instead, every interception attempt meant accepting high-speed diving attacks from above by heavily armed Thunderbolts that could strike with devastating effect, then escape before effective counterattack could develop. The psychological impact on Luftwaffe pilots was significant and grew more pronounced as American pilots became increasingly disciplined in applying energy tactics. German pilots, who had grown accustomed to Allied fighters accepting turning combat, discovered that Thunderbolts simply refused to fight on German terms. This fundamentally changed the risk calculation for Luftwaffe interception missions. Where previously German pilots could expect to force combat into envelopes where their aircraft advantages prevailed, by late 1943, they faced opponents who struck from positions of advantage and then disappeared before effective response could develop. The captured FW-190's contribution extended beyond tactical doctrine to influencing American fighter development programs. The testing at Wright Field provided detailed intelligence about what made the FW-190 effective, informing designers about characteristics that American fighters should prioritize. The exceptional roll rate came from well-balanced, relatively light ailerons and mass concentration near the aircraft centerline. American designers studied these principles and incorporated them into fighters under development. The FW-190's excellent cockpit visibility and ergonomic control layout demonstrated the combat value of reducing pilot workload through thoughtful design. Future American fighters emphasized these characteristics, recognizing that aircraft capabilities only translated to combat effectiveness when pilots could employ them efficiently under high-stress conditions. The testing also validated design decisions already made for fighters entering production. The Republic P-47's focus on high-altitude performance, rugged construction, and heavy firepower proved exactly correct for the strategic requirements of bomber escort over Europe, even though these characteristics created a fighter unsuited for traditional dogfighting tactics. German intelligence eventually learned that the British and Americans had captured an intact FW-190 and were conducting extensive testing, though the Luftwaffe never discovered the full extent of tactical intelligence derived from Faber's aircraft. German propaganda attempted to minimize the capture's significance, claiming that Allied powers already possessed detailed knowledge of FW-190 capabilities through combat experience and that one captured aircraft revealed nothing new. This assessment proved catastrophically wrong. Combat experience provided fragmentary, often contradictory information filtered through the chaos and stress of actual fighting. Systematic testing under controlled conditions revealed the precise performance characteristics and specific weaknesses that combat pilots often missed or misreported. The difference between knowing generally that an FW-190 could roll quickly and understanding specifically that its sustained turn performance degraded severely below 250 miles per hour was the difference between tactical theory and actionable intelligence. Oberleutnant Armin Faber spent the remainder of World War II as a prisoner of war in Canada, moved far from Europe to prevent any possibility of escape or rescue. He survived in the war and returned to Germany in 1947, living with the knowledge that his navigation error had provided the Allies with intelligence that contributed to Luftwaffe defeats throughout the remainder of the war. Faber rarely spoke publicly about the incident, understandably reluctant to discuss what he likely considered his greatest professional failure. He passed away in 1975, his role in Allied victory through inadvertent defection remaining relatively obscure outside aviation history circles. The captured FW-190 Werk No. 5737 flew numerous test flights at Wright Field through late 1943 and into 1944, accumulating hundreds of flight hours as American test pilots explored every aspect of its capabilities. The aircraft was eventually transferred to Freeman Field, Indiana, where it joined other captured German aircraft in the Foreign Equipment Evaluation Program. The fighter survived the war but was scrapped during the massive post-war disposal of military equipment, its intelligence value exhausted, and its preservation not considered a priority during the rapid demobilization that followed Japanese surrender. The tactical lessons learned from testing Faber's captured FW-190 spread throughout American fighter operations beyond just Thunderbolt units. P-38, Lightning, and later P-51 Mustang pilots received similar guidance about exploiting their respective aircraft's strengths against FW-190 weaknesses. The fundamental principle remained constant across all aircraft types: refuse combat on the enemy's terms, force engagements into performance envelopes where Allied fighters held advantages, and maintain the discipline to disengage when tactical situations became unfavorable. The strategic impact can be measured in the shifting balance of air superiority over Europe during late 1943 and throughout 1944. In spring 1943, when Thunderbolts first entered combat, 8th Air Force fighter units struggled badly against Luftwaffe opposition, suffering loss rates that threatened to make deep penetration bombing missions unsustainable. By early 1944, after the tactical lessons from the captured FW-190 had been thoroughly disseminated and incorporated into training and operational doctrine, American fighters were systematically destroying Luftwaffe fighter strength through a combination of superior numbers, increasingly skilled pilots, and tactical doctrine specifically designed to exploit German fighter weaknesses. The P-47 Thunderbolt went on to compile an impressive combat record in Europe, destroying more than 5,000 enemy aircraft in air-to-air combat while serving as both escort fighter and fighter-bomber throughout the strategic campaign. Much of this success came from pilots who understood they flew a specialized weapon designed for specific tactical employment rather than a universal dogfighter that could be thrown into any combat situation with expectation of success. The Thunderbolt's transformation from struggling heavyweight to dominant force directly resulted from tactical intelligence derived from systematic testing of captured enemy equipment. Captain Robert S. Johnson, who became the 8th Air Force's top-scoring ace in Europe with 27 confirmed victories before rotating home in May 1944, flew P-47 Thunderbolts exclusively throughout his combat tour. His success came from rigidly applying energy tactics, using altitude and speed to dictate engagement terms while refusing to accept combat in envelopes where enemy aircraft held performance advantages. Johnson credited much of his survival and success to understanding exactly what German fighters could and could not do, knowledge that came directly from the testing program that analyzed Faber's captured FW-190. The comparative test, a program at Wright Field, expanded throughout 1944 and 1945 as additional German aircraft were captured and shipped to the United States for evaluation. The Air Technical Service Command eventually accumulated examples of virtually every German fighter and bomber type, conducting systematic comparative trials that provided American pilots with detailed tactical intelligence about enemy capabilities. But Faber's FW-190 remained special, the first truly pristine example of Nazi Germany's most feared fighter to fall into Allied hands at a moment when that intelligence was desperately needed. The aircraft arrived at precisely the right time to influence tactical doctrine development for the P-47 Thunderbolt, before losses became so severe that the type might have been withdrawn from escort operations entirely. The timing was extraordinarily fortunate, a combination of Faber's navigation error, the aircraft's survival of the forced landing with minimal damage, and the rapid testing and dissemination of results that got tactical intelligence to operational units before the strategic situation deteriorated further. The story illustrates a fundamental principle of military intelligence. Understanding the enemy's capabilities and limitations provides advantages that can equal or exceed technological superiority. The FW-190 was objectively superior to the P-47 Thunderbolt in several important performance categories, particularly turning performance and roll rate. But once American pilots understood the German fighters' specific weaknesses and how to exploit them through disciplined tactical employment, the P-47's advantages in other areas, high-speed performance, dive acceleration, high-altitude capability, and rugged construction, became decisively more important than the areas where the FW-190 excelled. This tactical intelligence transformed an apparent disadvantage into operational superiority through systematic analysis and professional application of lessons learned. Modern military forces invest billions of dollars in intelligence gathering, technical exploitation of captured enemy equipment, and realistic training that prepares forces for actual enemy capabilities rather than theoretical assessments. The captured FW-190 program demonstrated why this investment remains essential. One captured aircraft, properly exploited through systematic testing and rapid dissemination of tactical lessons learned, influenced the outcome of thousands of subsequent combat engagements. The program's success depended on multiple factors converging effectively. British forces needed to capture the aircraft intact, requiring both Faber's navigation error and his controlled landing that left the fighter repairable. British and American intelligence needed to recognize the capture's significance and prioritize testing over other demands on limited resources and test pilot availability. Test pilots needed the skill to safely explore the FW-190's performance envelope while accurately documenting its characteristics. Intelligence officers needed to analyze test results and extract tactically relevant conclusions rather than simply compiling performance data. Training commands needed to develop effective methods for teaching new tactics to operational pilots, overcoming institutional inertia and pilot resistance to abandoning established procedures. Finally, operational commanders needed to enforce tactical discipline, ensuring pilots actually applied the lessons learned rather than reverting to instinctive responses under combat stress. The 8th Air Force accomplished all of these steps with impressive effectiveness, transforming raw intelligence from a captured aircraft into operational superiority within a matter of months. The speed of this transformation reflected the urgency created by mounting losses and the recognition that without fundamental changes in tactical doctrine, American fighter operations over Europe might fail to achieve their strategic objectives. By late 1944, as the combined bomber offensive reached its peak intensity and Allied forces advanced across France following the Normandy invasion, the Luftwaffe had been largely defeated in the air through a combination of overwhelming Allied numerical superiority, increasingly skilled Allied pilots, and tactical doctrines specifically designed to exploit German weaknesses. The captured FW-190 represented one thread in this larger tapestry of Allied victory, but an important thread whose influence spread throughout American fighter operations. The legacy of Faber's navigation error and the subsequent testing program extends into modern military aviation doctrine and practice. Every major military force maintains specialized units tasked with evaluating captured or acquired foreign military equipment, conducting systematic testing under controlled conditions, and rapidly disseminating tactical intelligence to operational units. The procedures and methodologies developed during World War II for exploiting captured enemy aircraft remain fundamentally relevant, adapted for modern technology, but based on principles established when test pilots first flew captured German and Japanese fighters. The captured FW-190 program demonstrated that technological advantage represents only one component of combat effectiveness. Tactical intelligence, training quality, pilot skill, numerical superiority, logistics capability, and industrial production all influence outcomes in complex interactions, where superiority in one area can compensate for disadvantage in others. The FW-190 was superior to the P-47 Thunderbolt in some important ways, but American forces leveraged their advantages to achieve operational dominance despite these German technological strengths. The transformation of the Republic P-47 from struggling, heavyweight to devastating aerial weapon system illustrated what became possible when technological capabilities aligned with tactical intelligence and professional application. The Thunderbolt possessed the performance characteristics necessary for success in the strategic bomber escort role, high-altitude capability, excellent dive performance, rugged construction, and heavy firepower. But these characteristics only translated into combat effectiveness once pilots understood how to employ them against specific enemy capabilities. The captured FW-190 testing provided that crucial understanding, revealing exactly how to leverage the P-47's strengths while avoiding engagements where German fighters held advantages. Thousands of Thunderbolt pilots flew combat missions over Europe equipped with tactical knowledge derived directly from Armin Faber's captured fighter. Many of these pilots survived encounters with FW-190s and other Luftwaffe fighters specifically because they understood enemy capabilities and knew how to fight effectively. The intelligence gathered from one captured aircraft, properly exploited and rapidly disseminated, influenced thousands of subsequent combat engagements over multiple years of intensive air warfare. The irony that a single navigation error by an experienced German pilot contributed significantly to Allied victory illustrates the role of chance in warfare. Faber's mistake was understandable, even predictable given the disorientation that commonly occurred during violent combat maneuvering and the navigational challenges of operating over water with limited instruments. But the consequences of that single error rippled through the remainder of the European air war, influencing tactical doctrine, training procedures, and combat outcomes far beyond anything Faber could have imagined when he lowered his landing gear over what he believed was occupied France. The British and American exploitation of this fortunate capture demonstrated professional military intelligence operations at their most effective. Both nations recognized the extraordinary value of obtaining an intact current production FW-190. They rapidly organized testing programs that extracted maximum intelligence value from the captured aircraft. They quickly disseminated tactical lessons learned to operational units through practical bulletins written by pilots for pilots. And they maintained security that prevented German intelligence from understanding the full extent of knowledge gained from the captured fighter. Modern historians continue studying the captured FW-190 program as an example of effective intelligence exploitation during World War II. The rapid transformation of raw intelligence into operational advantage, the systematic approach to testing that revealed both capabilities and weaknesses, and the successful dissemination of tactical lessons to combat units represent best practices that remain relevant for contemporary military forces. The program achieved its objectives, providing tactical intelligence that directly contributed to Allied air superiority over Europe, at minimal cost and with impressive speed. The contribution of one captured fighter to ultimate Allied victory cannot be precisely quantified, but its importance is undeniable. Testing Faber's FW-190 revealed specific tactical weaknesses at exactly the moment when American pilots needed that intelligence to survive and succeed against one of Nazi Germany's most capable fighters. The knowledge gained influenced aircraft development, tactical doctrine, training programs, and thousands of individual combat engagements. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.